Hi everyone, my name is Miss Fowry. In this video, I will be demonstrating how to answer the first 3 questions of the Grade 12 Mathematics Paper 1. This was the 2018 Mathematics Paper 1 question paper. Before you start answering the question paper, I will advise you to first take 3 to 5 minutes of your time to read the instructions and information properly. Now let's do question 1. For 1.1, you were instructed to solve for x. Starting with 1.1.1. X squared minus 4x plus 3 equals 0. This is a quadratic equation that we can solve by inspection. The factors of 3 that will give us the original quadratic equation are x minus 1 and x minus 3. Therefore, x is equal to 1 or 3. Now, 1.1.2. Five x squared minus 5x plus 1 equals 0, correct to 2 decimal places. It is hard or impossible to factorize this quadratic equation by inspection. Therefore, we will have to use the quadratic formula. It will be x equals minus b plus or minus the square root of b squared minus 4a, c, all over 2a. A will be equal to 5, b will be equal to minus 5, and c will be equal to 1. We plug them in and simplify. Minus 5 squared will give us 25. 4 times 5 times 1 will give us 20. Then 25 minus 20 will give us 5. In the denominator, we will get 10. Therefore, x is equal to 5 minus the square root of 5 over 10, or x is equal to 5 plus the square root of 5 over 10. Now, 1.1.3. X squared minus 3x minus 10 greater than 0. There are 2 ways of solving this inequality, either by using the graph method or finding the critical values of the inequality. Let's solve it by finding the critical points. We will treat it as if it is an equation and factor the left-hand side of the equation. The factors of 10 that will give us the original quadratic equation are x minus 5 and x plus 2. Set factors equal to 0. Then we get x is equal to 5, or x is equal to minus 2. Now, we can put back the inequality. Let's check intervals in between critical points. Test values in the intervals to see if they work. The interval minus 2 to positive 5 doesn't work in original inequality, but values work for the interval x less than minus 2 or x greater than 5. Therefore, x is less than minus 2 or greater than 5. Now, 1.1.4. Three square root of x equals x minus 4. We start by squaring both sides of the equation. Then move 9x to the other side. To get x squared minus 17x plus 16 equals 0. The factors of 16 that will give us 17 when added together are 16 and 1. Therefore, x is equal to 16 or 1. Now, 1.2. Solve simultaneously for x and y. 3x minus y equals 2 and 2y plus 9x squared equals minus 1. We simplify 3x minus y equal 2 and make it the second equation. Then substitute the second equation into the first one and solve for x. Divide both sides by 3 to simplify. Factorizing this quadratic equation gives us 3x minus 1 times x plus 1. X is equal to 1 over 3 or minus 1. If we substitute these values into the second equation, we will get y is equal to minus 1 or 5. Therefore, x is equal to 1 over 3 or minus 1. And y is equal to minus 1 or 5. Now, 1.3. If 3 to the power 9x equals 64, calculate without the use of a calculator the value of 3 to the power x minus 1 inside cube brackets over the square root of 5 to the power p squared. We start by removing the cube brackets on the numerator. Then it becomes 3 to the power 3x times 3 to the power minus 3 over the square root of 5 to the power square root of p. In the denominator, we swap the exponent of 5, which is 1 over 2, with the square root of p, so that we can be able to substitute it with 64. We know from earlier statements that 5 to the power square root of p is equal to 64. And also 3 to the power 3x is equal to 4. We then substitute and simplify. In the numerator, 3 to the power minus 3 is the same as 1 over 27. In the denominator, the square root of 64 becomes 8. Simplify until we get our final answer of 1 over 54. Now let's do question 2. For 2.1, we have to answer 3 questions based on the given quadratic sequence. Starting with 2.1.1. The question says, write down the next term of the sequence. This is just for 1 mark, so you can just write the final answer. But we know that the second difference is 6, so to get the next term, we will have to add the last term by 19. So 23 plus 19 will give us 42. And that is the answer. Now 2.1.2. Determine the nth term of the sequence. We first have to find a. Let's rewrite the sequence and try to first find the first difference by subtracting the current term by its previous. We do this again to get the second difference, which is 6. To get a, we divide the second difference by a constant 2, and we get 3. We then plug it in. To get b and c, we will have to use simultaneous equations. If n is equal to 1, we get 3 plus b plus c equals 2. Simplify it to get our first equation. If n is equal to 2, we get 12 plus 2b plus c is equal to 3. Simplify it to get our second equation. We subtract t2 by t1 to get b. Then we sub b in the first equation and solve for c. And get 7. Now we have a is equal to 3, b is equal to -8, and c is equal to 7. We then plug them into the quadratic formula. And our final answer is Tn is equal to 3n squared minus 8n plus 7. Now 2.1.3. Calculate the 20th term of the sequence. We can use the nth term formula that we just calculated previously. If we substitute n with 20, we get our final answer of 1047. Now 2.2. Given the arithmetic sequence of 35, 28, 21, calculate which term of the sequence will have a value of minus 140. First, find a and common difference. A is equal to 35. The common difference is equal to minus 7. Then we plug them in and simplify. And we get minus 7n plus 42. Now we will use this equation to find the term. Let's plug in minus 140 and solve for n. We then get n is equal to 26. And this is the final answer for 2.2. Now 2.3. We can either use the last term or the common difference formula. Let's use the common difference formula. We know that a is equal to 35 and d is minus 7. We plug them in and simplify. Then we plug in 3n squared minus 8n plus 7 on the left-hand side and solve for n. We then get n minus 7 times 13n minus 2. N is equal to 7, or n is equal to 2 over 13. But the n term cannot be a fraction, therefore n is equal to 7. Now question 3. A geometric series has a constant ratio of 1 over 2 and a sum of infinity of 6. 3.1. We are asked to calculate the first term of the series. We know that the constant ratio is 1 over 2. And sum to infinity is equal to 6. We can find the first term by using this formula. As stated earlier, our sum to infinity is 6 and the constant ratio is half. In the denominator, 1 minus half is equal to half. Then we multiply both the numerator and denominator by 2. Divide both sides by 2 to get our final answer of a is equal to 3. Now, 3.2. Calculate the eighth term of the series. To calculate the eighth term of the series, we will use this formula. Tn is equal to ar to the power n minus 1. N is equal to 8, a is equal to 3, and the constant ratio is equal to half. 1 over 2 to the power 7 will give us 1 over 128. Therefore, our eighth term is 3 over 128. Now, 3.3. Given sum of 3, 2 to the power L minus k is equal to 581.25. Calculate the value of n. The first three terms of the series are 3, 3 over 2, 3 over 4. This is a geometric series, with the constant ratio being equal to 1 over 2. And a is equal to 3. We can use this formula to find the sum of a geometric sequence. We plug in the values we have found and solve for n. On the left-hand side, we divide both the numerator and denominator by 2. Then we divide both sides by 6. On the left we get 1 subtracted by 0.5 to the power n. On the right, 0.9687. Take 1 over 2 to the power n to the other side. Then we add logs to both sides. and divide both sides by log of 0.5. The value of n is 5. Now, 3.4. If 3 2 to the power L minus k. Write down 24 2 to the power minus k in terms of p. There are a couple of ways of doing this, but we will write the sum in terms of p, using the geometric series sum formula. N is equal to 20, A is equal to 3, constant ratio is equal to 1 over 2. When A is equal to 3, we get 6. When A is equal to 12, we get 24. (24) divided by 6 gives us 4. So the sum to the 20th term in terms of p is 24 equals 4 times 6 and 4p. And that's it for question 3.